So in the last lecture, I was teaching you SRTF algorithm, shortest remaining time first. So what's the advantage of this algorithm? It doesn't suffer from convoy effect. As we know that FCFS algorithm, it suffers from convoy effect, but there is no convoy effect in case of SRTF algorithm. Okay. So also the other disadvantages are there. It has better throughput. It has better throughput and also lower waiting time and turnaround time. So just note down the point that it has better throughput. Okay, let me write here. Okay, I write here. Better throughput and lower wait time and turnaround time. Okay, so it's an advantage of shortest remaining time first algorithm. And another important point is to be noted is in preemptive algorithm like SRTF. Okay, let me rub this first. In the preemptive algorithm like SRTF, we always have waiting time is equal to, in a non-preemptive algorithm, I am telling about non-preemptive algorithm like SJF and FCFS, waiting time is equal to response time in non-preemptive algorithm. But in preemptive algorithm, you have already seen waiting time may not be equal to response time. Okay, so it's an important point to be noted. They may ask questions like they will give some options and they will ask which of these are correct. There may be options like in case of preemptive algorithm, waiting time is in case of non-preemptive algorithm, waiting time is equal to response time. Then you should select this option. Okay. Okay, don't worry. I will solve another question of shortest remaining time first, because I know it's somewhat difficult. But if you solve more and more questions, then it will be beneficial for you because your basic concepts will be more clear. Okay, so let me solve another question. Just give me a time. So let's solve this question. We have process ID, then we have arrival time, then we have burst time. Okay, it's a small question, just three processes are there: P1, P2, P3, and the arrival times are 0, 1, 2, 0, 1, 2, and the burst times are 13, 5 and 22. 13, 5 and 22. So here we have to find out average turnaround time and average waiting time. So how to solve? Using SRTF, let's solve it. First draw a Gantt chart. Okay. Now you see at t is equal to 0th second, how many processes are available? Only P1, because P1 arrived at t is equal to 0 second. So here we will write P1. After 1 second, after 1 second, how many available processes are there? P2. Okay, so P1 and P2 are there from 0 to 1. Okay, and also since P1 has executed for 1 second. So how much time is left for P1? It has already, out of 13 seconds, it has already executed 1 second. So P1 has 12 seconds left. Okay. So out of P1 and P2, which process has lower burst time? P2, because P2 has 5 seconds and P1 has 12 seconds. So here there will be a context switching. P1 will be preempted and CPU will be given to P2. Okay. Now, after execution of 1 second, you see P3 has also arrived. It means what? From 0 to 2 seconds, P1, P2, P3 are available because P3 has arrived at 2 seconds. So at 2 seconds, P3 has arrived. Okay. So you see here, and also since P2 has executed for 1 second, so how much time is remaining for P2? 4 seconds. So now you see, since all the 3 processes are available, so you have to select the process with the lowest burst time. So among P1, P2 and P3, which process has the lowest burst time? P1, 12 seconds left, P2, 4 and P3, 22. So obviously P2 has the lower burst time. So rather than context switching, CPU will remain with P2 here. It means what? CPU will not be given to P3. Why? Because P3 has higher burst time than P2. Okay. So CPU will remain with P2. So here there will be no context switching. Okay. Now, again, yes, P2. So now you can see that, yes. So here you can guess that all the 3 processes are available now. So from here, you can simply apply shortest job first algorithm. I already told you in the previous example. Then if we have all the process available, then we can apply shortest job first. That is non-preemptive algorithm. Okay. So since all the processes are available, so simply we can execute P2 fully. So how much time is left for P2? 4 seconds. So we can execute P2 fully. So 1 plus 4, 5. So job of P2 is done. So from here we can remove P2. P2 is not here. Now how many processes are available? P1 and P3. Okay. So among P1 and P3, which process have lower burst time? Obviously P1. So now there will be a context switching. CPU will be given to P1 again. Okay. And since all the processes are available, so we simply apply shortest job first. It means there will be no preemption. So P1 will be executed fully for 12 seconds because 12 seconds were left for P1. So 5 plus 12, I think 17. Okay. So P1 has executed fully. So now process P3 is left. So execute process P3. P3 has 22 seconds. So then here will be 39. 17 plus 22, 39. So you see here how many context switching has happened. So here I should write only P2. Okay. So here how many context switching happened? 1, 2, 3. So number of context switching is equal to 3. Okay. Okay. So you take care of the calculation part because maybe I don't know. Maybe if there is any calculation mistake, there can be a calculation mistake. So you just calculate it carefully. Okay. So don't completely rely on my calculations. Okay. So Now, since the Gantt chart is completed, so let's calculate the average turnaround time. Okay, so I'm roughing this. Here I should write 13, 5 and 22. 13, 5, 22. So now let's write here the completion time. Completion time of process P1 is 17 seconds, not 1 second, 17 seconds, because at 17 seconds process P1 is completed. Completion time of process P2 is 5 seconds. Yes. Completion time of process P3 is 39 seconds. Fine. So now let's calculate the turnaround time. What is the formula of turnaround time? Completion time minus arrival time. Completion time minus arrival time. Fine. So let's calculate the for P1, 17 minus 0 is equal to 17. For P2 it will be 5 minus 1, 4. For P3 it will be 39 minus 2, 37 seconds. Okay. So let's calculate the wait time. So what's the formula for waiting time? Turnaround time minus burst time. Turnaround time minus burst time. So let's calculate the waiting time. Turnaround time minus burst time. 17 minus 3, 4. So waiting time of P1 is 4 seconds. Waiting time of P2 is 'So I think here I made some mistake, because turnaround time minus burst time. Here turnaround time is lesser than the burst time. How is it possible? Here it will be completion time is 5 for P2. Completion time minus arrival time 4. So how is it possible? Okay, here I've made a mistake. You see, here the burst time is 5 seconds. Okay, so here P2 will run for 5 seconds. From 1 second it will start and run till. So here I've made a mistake. So then everything will be changed. Okay. So here then, here it will be 6. Okay. Sorry. Here it will be 1 plus 5 is equal to 6. Then P1 will be again given. So P1 will execute for 12 seconds. Here it will be 18. And here it will be 40. So the completion time will change accordingly. Completion time of P1 will be 18. Completion time of P2 will be 6. And completion time of P3 will be 40. Okay. Yes. Yeah. So now let's calculate the turnaround time. So here you have to be very careful while calculating. Okay. Because even a single calculation mistake may lead to you at even a single calculation mistake may lead to you in a trouble, okay, in the GATE exam, because there you will not get much time. You have to solve every question, and it should hardly take not more than 2 to 3 minutes. Okay, so turnaround time is completion time minus arrival time. Completion time minus arrival time for P1. Completion time minus arrival time for P2. Completion time minus arrival time for P3, 38. And waiting time, turnaround time minus burst time, 18 minus 13, 5. Then turnaround time on the burst time for P2, 5 minus 5, 0. And for P3, 38 minus 22, 16. So here we have calculated the waiting time of all the three processes. Okay. So let's see. So let's use our intuition and see how the waiting times are 5, 0, and 16. Here we have calculated it mathematically, but let's understand how it's 5 seconds. You see, the waiting time of P1 is 5 seconds because although P1 immediately got the CPU, but it had to wait for 5 seconds in the ready queue. It had to wait for 5 seconds in the ready queue to again get the CPU. So overall, P1 waited for 5 seconds. Okay. And let's see about P2. So at t is equal to 1 second, P2 immediately got scheduled. And P2 ran till its completion. It ran till t is equal to 6. It means what? P2 didn't leave the CPU. P2 completed its task. After that, it left the CPU. Let's see why the waiting time of P3 is 16 seconds. Because you see, P3 arrived at 2 seconds, but it waited till 18 seconds. So here you see, arrived at 2 seconds and waited till 18 seconds. So here you see the waiting time is obviously 16 seconds because after 16 more seconds, it got the CPU. So the wait time is 16 seconds. Now calculate the response time. So how to calculate the response time? Let's calculate the response time of P1. P1 arrived at 0 and immediately got scheduled. So response time of P1 is 0. What's the response time of P2? P2 arrived at 1. P2 arrived at 1 and immediately got scheduled. So P2 started responding as it got arrived. 0. And what's the response time of P3? P3 arrived at 2 but got scheduled at 18. So the response time of P3 will be 18 minus 2, 16. Okay. So from here you can calculate the average turnaround time and average wait time. So how? Average turnaround time 18 plus 5 plus 38 by 3. You just calculate, and average wait time is 5 plus 0 plus 16 by 3. Okay. So that's all about shortest remaining time first algorithm. Okay. So we will see more question once after finishing round robin algorithm and priority algorithm. We will see more great previous year's questions. Okay. So I hope SRTF is clear to you. Okay. Fine.